Hello learners, welcome back. Today I want us to learn how to solve a 3 by 3 matrix using cofactor method, and we are going to solve this equation, and I hope that we are going to learn together till the end. Okay, when given this kind of equation and you have been asked to solve a 3 by 3 matrix to find the value of x1, x2 and x3, first of all you are going to write this equation in form of a matrix form such that you are going to get 4, 1, negative 5, negative 2, 3, 1, 3, negative 1, 4, x1, x1, x2, x3 is equals to 8, 12, and 5. Then the steps of solving a cofactor, using cofactor method. First of all, we are going to find the minus. Then next we will get the cofactors. Then next the adjoint. Next the determinant. The inverse. And inverse is usually 1 over the determinant multiplied by the adjoint. Then lastly, now we are able to solve for the values. Now these are the steps that we are going to follow so as we are able to get to solve those values. So first of all, we are going to start with the minors. And the minors are usually, so for the minor, given this kind of matrix, 4, 1, negative 5, negative 2, 3, 1, 3, negative 1 and 4. Then when we are asked to find the minors are usually, you're going to find the minor M11, M12, M13, M21, M22, M23, M31, M32, and M33. Those are the minors. So to get the minor, this minor here, M11, you are going to get to multiply the values that are not in row 1 and column 1, such that the ones that are not in row 1 and column 1, which are 3, 1, negative 1 and 4. So you are going to get 3 times 4 less negative 1 times 3 times 4 less negative 1 times 1, and with that you are going to get the value as 13. Then next M12. Get M12, the ones that are the values that are not in row 1 and column 2. Row 1, column 2, which are negative 2 and 4. You less 3 times 1. So you are going to get negative 2 times 4. I'm going to get negative 11. Then next M13. M13, the ones that are not in row 1 and column 3, which are negative 2 times negative 1 less 3 times 3. Which is negative 7. Then M21, the ones that are not in row 2, column 1, which are 1 times 4, you less negative 1 times negative 5. Which is negative 1. Then M22, the ones that are not in row 2 and column 2, row 2, column 2. So you are going to get 4 times 4 is less negative 5 times 3. Which is 31. Then M23, not in row 2 and column 3, which is 4 times negative 1 plus 3 times 1, which is negative 7. Same case to M31, the ones that are not in row 3 and column 1. So we are going to get it's 1 times 1 minus 3 times negative 5, which is 16. And M32, not in row 3 and column 2, which is 4 times 1 less row 3 and column 2. 4 times 1 and negative 2 times negative 5, which is negative 6. Then the last one M33, the one not in row 3 and column 3, which is 4 times 3 plus negative 2 times 1, which is 14. So now you are going to replace them just the way they are as the minus. So minus 1, 1 is 13, minus 1, 2, negative 11, negative 7, negative 1, 31, negative 7, 16, negative 6, and 14 as the last one. So from the minus, the next step now is to get the cofactors after you have gotten the minus. So cofactor, it is usually you take the minus that you have gotten, these are the minus, you multiply with the sign. In that case, you now take this minus 13, negative 11, negative 7, negative 1, 31, negative 7, 16, negative 6, 14. You multiply with the signs. And to multiply with the signs, you are supposed to start with a positive sign. Then they alternate negative, positive, negative, positive, negative, positive, negative, positive. So that you are able to get the cofactors. So this is going to be 13, negative 11 times negative, that's 11, negative 7, 1, 31, 7, 16, 6, and 14. Now that is the cofactor that you are going to get. Then from the cofactor, next you get the adjoint. When the adjoint, it's usually cofactor transpose. And by cofactor transpose, we mean that the rows in the cofactor, the rows in the cofactor will become the column in the adjoint. So meaning this 13, 11, negative 7, row 1 will become column 1, row 2 will become column 2, row 3 will become column 3. That is the adjoint. So now from the adjoint, next is finding the determinant. In order to get the determinant is usually A11, A11, A12, A12, A13, A13. You're going to take the first row of the cofactor, you multiply with the first row of the initial matrix that you have. So meaning the row 1 column 1 of the initial matrix is 4, you multiply with the row 1 column 1 of the matrix of the cofactor, which is 13. Then you add 1 times 11, then negative 5 times negative 7. Remember, you are able to get, for you to get the determinant. So you are going to get the determinant as 98. So the next step is to get the inverse. In the inverse, it's usually 1 over determinant. You multiply now with the adjoint. 1 over this determinant, you multiply with this adjoint. Meaning, so the inverse is 1 over determinant times adjoint. And in our case, the determinant is 98. You multiply with 13, 11, negative 7, 1, 31, 7, 16, 6, and 14. For you to be able to get the inverse. So, getting the inverse, we are going to get it as 13 over 98, 1 over 98, 16 over 98, 11 over 98, 31 over 98, 6 over 98, negative 7 over 98, 7 over 98, and 14 over 98. Those are the inverse. So our last step is now to solve the value. So for the values, and to solve, you multiply the inverse both sides. Both sides. So meaning this inverse, you are going to multiply it, this one and the other part, the left hand side and the right hand side. So for you to solve it, you are going to write the inverse, which is 13 over 98, 1 over 98, 16 over 98, 11 over 98, negative 7 over 98, 31 over 98, 7 over 98, 6 over 98, 14 over 98. You multiply it with 4, negative 1, negative 5, negative 2, 3, 1, 3, negative 1, 4, x1, x2, x3. So this is the right hand side is equals to the same inverse, multiply now with the 8, 12, and 5. So 13 over 98, 11 over 98, negative 7 over 98, 1 over 98, 31 over 98, 7 over 98, 16 over 98, 6 over 98, 14 over 98. You are supposed to multiply 8 with 8, 12, and 5. So first of all, we can multiply these ones. When you multiply on this side, you are supposed to get it as, they're supposed to remain as 1, 0, 0, 0, 1, 0, 0, 0, 1. That's always the case. When you multiply, you are supposed to get an identity matrix. So you are going to be left with it as that way, x1, x2, x3 is equals to, now main focus is to multiply on the right hand side. The one that is 13 over 98, 1 over 98, 16 over 98, 11 over 98, 31 over 98, 6 over 98, negative 7 over 98, 7 over 98, and 14 over 98. You multiply 8 with 8, 12, and 5. So for you to get the value of x1, it's going to be, you multiply this row 1 and column, and this is the column that you have. So in that case, x1 will be 13 over 98 multiplied by 8. You add 1 over 98 multiplied by 12. You add 16 over 98 multiplied by 5 in order to get the value of x1. Then x2, so then x2 also will be 11 over 98 multiplied by 8. You add 31 over 98 multiplied by 12. You add 6 over 98 multiplied by 5. And then lastly, value of x3 as negative 7 over 98 multiplied by 8. 100 with 7 over 98 multiplied by 12, then 14 over 98 multiplied by 5. Now that you have to be able to get those values. So to get for the value of x1, 13 over 98 times 8, you add with 1 divided by 98 times 12 plus 16 over 98 times 5. You're going to get the value as x1 as 2. Then next, you're going to get the value of x2, 1 over 98 times 8. You add 3 over 98 times 12. Then 6 over 98 times 5. So this one is going to be 1. And now x3 negative 7 divided by 98 times 8. 7 divided by 98 times 12. So, I'm sorry, this one is supposed to be 1 and this one is supposed to be, the value of x2 is supposed to be 5. So that's the values that you're going to get. Yeah. See you next. Bye.